So let's try to solve first question. 2A gives B plus C. It would be a zero order reaction when option A, rate of reaction directly proportional to the concentration of A raised to the power 2. The rate of reaction remains same at any concentration of A. Option C, the rate of reaction remains same at any concentration of B and C. Option B, the rate of reaction doubles if the concentration of B is increased to double. For a zero order reaction, when you write the rate law, you will get rate is equal to rate constant into concentration of reactant raised to the power 0. That means rate of reaction doesn't depend on the reactant concentration. So the answer will be B. The rate of reaction remains same at any concentration of A. Now come to the next question. For the reaction 2N2O5 gives 4NO plus O2. Rate and rate constants are 1.02 into 10 raised to minus 4 molar per second and 3.4 into 10 raised to minus 5 per second respectively. Then concentration of N2O5 at that time will be, and these are the options. To solve this equation, we need to write the rate law. How do we write the rate law without knowing the order of reaction? And it is not given in the question. But from the unit of rate constant, we can know the order of reaction. The unit of rate constant is given per second, and this is the unit for the first order rate constant. That means the order of reaction is not directly given in the question, but it is given in the form of rate constant. So now you can write the rate law for the given equation. The rate will be equal to rate constant into concentration of A. We have to find out the concentration of A. Rate is given, rate constant is also given in the question. Now rearrange the equation to get the reactant concentration A. So A will be equal to rate of the reaction over rate constant. Now place the values given in the question. A will be equal to 1.02 into 10 raised to minus 4 molar per second over 3.4 into 10 raised to minus 5 per second. So per second and per second will get cancelled out. And when you solve this equation, you will get A is equal to 3 molar. So the option B will be the right option for this question. Now come to the next question. The reaction A gives B follows first order kinetics. Time taken for 0.8 moles of A to produce 0.6 moles of B is 1 hour. What is the time taken for the conversion of 0.9 moles of A to produce 0.675 moles of B? So here we have to calculate time. It is a first order reaction. So we can use our formula K is equal to 2.303 over T log A naught over AT. So A naught and AT is given in the question, but we don't know the value of K. So first you have to calculate the value of K, then we can calculate the value of T. Now write down the equation where A gives B. At time T is equal to 0, 0.8 moles of A is given, and after 1 hour 0.6 moles of B are produced. That means after 1 hour, how much amount of A will remain? There will be 0.8 minus 0.6 moles of A will remain at the time 1 hour. So it is equal to 0.2 moles. Concentration of A at time T0 is equal to A naught, and the concentration of A at time 1 hour is equal to AT. So place the values in the given equation. So you will get K is equal to 2.303 over 1 hour log 0.8 moles over 0.2 moles. So when you solve this equation, you will get the value of K is equal to 1.38 per hour. Now we have calculated the rate constant, that is 1.38 per hour. And we have to calculate the time taken for this conversion. So write down the reaction where A gives B. At time T is equal to 0, 0.9 moles of A are given, and at the time T, 0.675 moles of B are produced and we have to calculate this time T. At this time, how much amount of A will remain? 0.9 minus 0.675 moles will be equal to 0.225 moles will remain. Concentration at T is equal to 0 time is equal to A naught, and this concentration will be equal to AT. So now you can use the formula A is equal to 2.303 over T log A naught over AT. Now place the values in the given equation. So you will get 1.38 per hour is equal to 2.303 over T log 0.9 over 0.225. Now rearrange the equation to get the value of T. So you will get T is equal to 2.303 over 1.38 per hour log 0.9 moles over 0.225 moles. When you calculate this equation, you will get T is equal to 1 hour. So option A will be the right option for this question. Now come to the next question. For a first order reaction, A gives B. The reaction rate at reactant concentration of 0.01 molar is found to be 2 into 10 raised to minus 5 mole per liter per second. The half-life period of the reaction is, and these are the options. Here we have to calculate the T-half. For the calculation of T-half, for first order reaction, we have the equation T-half is equal to 0.693 over K. To calculate the T-half, we will require rate constant, but it is not given in the question. So first you have to calculate the rate constant. For the calculation of rate constant, we have to write the rate law for first order reaction. Rate law will be equal to rate of reaction is equal to rate constant multiplied by the concentration of reactant raised to the power 1 as it is the first order reaction. Rate of reaction is given in the question. Reactant concentration is also given in the question. So place the values in this equation. So you will get 2 into 10 raised to minus 5 mole per liter per second is equal to rate constant multiplied by 0.01 molar. Molar can also be written as moles per liter. So here molar and moles per liter will get cancelled out. And when you solve this equation, you will get the value of K is equal to 2 into 10 raised to minus 3 per second. Now we have calculated the rate constant. Now place the value of rate constant in this equation. So you will get T half is equal to 0.693 over 2 into 10 raised to minus 3 per second. 0.693, when you remove this decimal sign, you will get 10 raised to minus 3. 10 raised to minus 3 and 10 raised to minus 3 will get cancelled out. And when you divide it, you will get 346.5. And the value of T half is closer to the option D. So the option D will be the right option for this question. Now come to the next question. The rate of reaction between two reactants A and B decreases by a factor 4 if the concentration of reactant B is doubled. The order of reaction with respect to B is, and these are the options. To solve this equation, first you have to write the rate law with respect to B. So you will get rate of reaction is equal to rate constant multiplied by the concentration of B raised to the power x. We have to find out the value of this x. For set 1, the concentration of B, if we take it as B. So you will get R1 will be equal to rate constant multiplied by B raised to the power x. As it is given in the question, the concentration of B is doubled. That means concentration of B, we can take it as 2B. So now place the value of concentration of B for set 2. So here you will get R2 will be equal to rate constant multiplied by 2B raised to the power x. On doubling the concentration of B, rate of reaction decreases by factor 4. That means R2 will be equal to R1 by 4. So here you will get R1 by 4 is equal to K 2b raised to the power x. Now we have two equations. Equation 1 and this is the equation 2. If you divide both the equation, you will get R1 over R1 by 4 is equal to K b raised to x over K 2b whole raised to the power x. So here R1 will get cancelled out with R1, K will get cancelled out with K, b raised to the power x will get cancelled out with b raised to the power x, and you will get 4 is equal to 1 over 2 raised to the power x. So you can rewrite this equation as 4 is equal to 2 raised to the power minus x. Now you can find the value of x. So here the value of x will be minus 2. And the option B will be the right option for this question. Now come to the next question. If 60% of first order reaction was completed in 60 minutes, 50% of the same reaction would be completed in approximately. And these are the options. To solve this question, first write down the reaction. For example, A gives B. At time t is equal to 0, initially there were 100% concentration of A, but after 60 minutes, 60% of the reaction was completed. Means 60% converted into the product. So how much amount will remain after 60 minutes? So there will be 100 minus 60 means 40% concentration will remain at the time 60 minutes. So this can be equal to A naught and this is equal to 80. In the question, it is asked to calculate the time for the completion of 50% of the reaction. That means actually we have to calculate T half, and for the calculation of T half we have the formula 0.693 over K. But we don't know the value of K. So first of all you have to calculate the value of K. By using the equation K is equal to 2.303 over T log A naught over AT. We just have calculated the value of A naught and AT. So place the values in the given equation. So you will get K is equal to 2.303 over 60 minutes log 100 over 40. So here when you calculate it, you will get K will be equal to 0.015 per minute. So we have calculated the value of rate constant. Now you can calculate T half. Now place the value of K in the given equation. So you will get T half will be equal to 0.693 over 0.015 per minute. When you calculate it, you will get 45.5 minutes. And this value is closer to option A. So the option A will be the right option for this question. Now come to the next question. The rate constants K1 and K2 for two different reactions are 10 raised to 16 e raised to minus 2000 over T and 10 raised to 15 e raised to minus 1000 over T respectively. The temperature at which K1 is equal to K2 is. So let's suppose where K1 is equal to K2. Now place the values. So here 10 raised to 16 multiply by e raised to minus 2000 over T will be equal to, here I have placed the value of K2, 10 raised to 15 e raised to minus 1000 over T. Now transfer the number terms on one side of the equation. So here you will get 10 raised to 16 over 10 raised to 15 e raised to minus 2000 over T is equal to e raised to minus 1000 over T. When you solve it, you will get 10. Take the natural log of both sides of the equation. So you will get ln 10 minus 2000 over T is equal to minus 1000 over T. Now transfer this term to the other side of the equation. So you will get ln 10 is equal to minus 1000 over t plus 2000 over t. Now solve this equation. So you will get ln 10 is equal to 1000 over. Now convert this equation into log to the base 10. So you will get 2.303 log 10 is equal to 1000 over t. Log 10 is equal to 1. So you will get 2.303 is equal to 1000 over t. So from here you can calculate the value of t. It will be equal to 1000 over 2.303. Option B will be the right option for this question. Now come to the next question. During the kinetic study of reaction 2A plus B gives C plus D. Following results were obtained. What will be the rate law? To solve this type of question, first you have to write the rate law. So rate will be equal to rate constant multiplied by A raised to the power x multiplied by B raised to the power y. You have to select two results in which the concentration of one reactant is kept constant while varying the concentration of other reactant. So if we choose set 1 where the concentration of A is 0.1 and concentration of B is 0.1, now you have to select the set in which the concentration of any one of the reactant is kept constant. So here in fourth set of reaction, concentration of B is kept constant while the concentration of A varies. So first write down the rate law for first set of reaction. So we will get rate 1 will be equal to A multiplied by the concentration of A, that is 0.1 raised to the power x multiplied by concentration of B, that is 0.1 raised to the power y, and it is equal to 6 multiplied by 10 raised to minus 3. Now write the equation for fourth set. So you will get rate 4 will be equal to A multiplied by 0.4 raised to the power x multiplied by 0.1 raised to the power y, and it is equal to 2.4 into 10 raised to minus 2. Now we have two equations. This is equation 1 and this is equation 2. Now divide both the equations. So you will get A 0.1 raised to the power x multiplied by 0.1 raised to the power y divided by k 0.4 raised to the power x multiplied by 0.1 raised to the power y is equal to 6 into 10 raised to minus 3 divided by 2.4 into 10 raised to minus 2. K and k will get cancelled out. 0.1 raised to the power y will get cancelled out by 0.1 raised to the power y. Here, when you remove this decimal point, you will get 10 raised to the power minus 3 here. Now, 10 raised to power minus 3 and minus 3 will get cancelled out. And you can divide this value. And here, this decimal point can get cancelled out with this decimal point. So here you will get 1 over 4 whole raised to the power x is equal to 1 by 4. So from here, you can calculate the value of x. So here, x will be equal to 1. So you will get the rate law. Rate will be equal to rate constant multiplied by A raised to the power 1 because we just have calculated the value of x, that is equal to 1. Now we have to calculate the value of y. Now you have to select the set of reactions in which concentration of A is constant. So in second set and in third set, concentration of A is constant while concentration of B varies. So write down the rate law for second set. So you will get rate 2 will be equal to rate constant multiplied by 0.3 raised to 1 multiplied by 0.2 raised to the power y is equal to 7.2 into 10 raised to minus 2. For set 3, you will get rate 3 will be equal to rate constant multiplied by 0.3 raised to 1 multiplied by 0.4 raised to power y is equal to 2.88 into 10 raised to minus 1. Now this is the equation 1 and this is the equation 2. we have to divide both the equation to calculate the value of y. So you will get k 0.3 multiplied by 0.2 raised to power y divided by k into 0.3 multiplied by 0.4 raised to the power y is equal to 7.2 into 10 raised to minus 2 divided by 2.88 into 10 raised to minus 1. So here 0.3, 0.3 will get cancelled out, k will get cancelled out with the k, and here when you remove this decimal point, you will get 10 raised to minus 1, and when you remove this decimal point, you will get 10 raised to minus 2. And this decimal point will get cancelled out with this decimal point. This term will get cancelled out with this term, and here when you divide it, you will get 1 by 4. So you will get 2 by 4 raised to the power y is equal to 1 by 4. Here you can divide it and you will get 1 by 2 raised to the power y is equal to 1 by 4. That means the value of y will be equal to 2. So now we have calculated the value of x, that is equal to 1, and value of y we have calculated it as 2. So the rate law will be equal to rate constant multiplied by concentration of A multiplied by concentration of B raised to the power 2. So the option D will be the right option for this question. Now come to the next question. The rate of reaction 2NO plus Cl2 gives 2NoCl is given by the rate law. Rate is equal to rate constant multiplied by concentration of NO raised to the power 2 multiplied by the concentration of Cl2. The value of rate constant can be increased by, and these are the options. Rate constant doesn't depend on the reactant concentration. It is a constant and its value remains same for our reaction. Whenever you multiply the reaction or divide the equation, no mathematical operation can apply on the rate constant. Rate constant can only depend on the temperature. So if you want to increase the rate constant, you have to increase the temperature. Now come to the next question. The rate of reaction for 2N2O5 gives 4NO2 plus O2 can be written as minus dN2O5 over dt is equal to K1 concentration of N2O5 and dNO2 over dt is equal to K2 multiplied by the concentration of N2O5 and dO2 over dt is equal to K3 multiplied by the concentration of N2O5. The ratio between K1, K2 and K3 is, and these are the options. To solve this question, apply the concept of instantaneous rate. So when you write the instantaneous rate for this given equation, you will get rate of reaction is equal to minus 1 by 2 dN2O5 over dt, where 2 is the coefficient of N2O5. It is also equal to plus 1 by 4 dNO2 over dt, where 4 is the coefficient of NO2, and it is also equal to plus dO2 over dt. In front of oxygen, nothing is written, that means the coefficient of oxygen is 1. Now place the value of dN2O5 over dt that is given in the question is equal to K1N2O5. So you will get 1 by 2 K1N2O5. The value of dNO2 over dt is given K2 multiplied by the concentration of N2O5. So here you will get 1 by 4 K2 N2O5. The value of dO2 over dt is given K3 multiplied by the concentration of N2O5. So here I have written K3 multiplied by the concentration of N2O5. So here N2O5 will get cancelled out from each of the equation. To get the simplest ratio, we need to multiply this whole term by 4. So when you multiply it by 4, you will get 2K1 is equal to 1K2 is equal to 4K3. So in this way, you will get the ratio 2 ratio 1 ratio 4. So the option B will be the right option for this question. Now come to the next question. For a reaction A plus B gives C plus D. Doubling the concentration of only B doubles the rate of reaction, while doubling the concentration of both the reactants increases the rate by 8 times. So the rate law will be, and these are the options. To solve this question, first write down the rate law. So rate will be equal to rate constant multiplied by concentration of A raised to the power x multiplied by the concentration of B raised to the power y. For first set, if we take concentration of A is equal to A and concentration of B is equal to B. So you will get rate will be equal to K multiplied by A raised to the power x, B raised to the power y is equal to R. For set 2, on doubling the concentration of B, means here we are going to take the concentration of B is equal to 2B and we keep the concentration of A remain A. So you will get rate 1 will be equal to K A raised to the power x multiplied by 2B raised to the power y is equal to 2R. Because in the question it is given on doubling the concentration of only B doubles the rate. Means rate for set 2 will be double of the rate of set 1. Now this is the equation 1 and this is the equation 2. So now we divide both the equation. So you will get A raised to the power x multiplied by B raised to the power y divided by K A raised to x multiplied by 2B whole raised to y is equal to R divided by 2R. R will get cancelled out with R. K will get cancelled out with K. A raised to x will get cancelled out with A raised to x. So here you will get B over 2B whole raised to the power y is equal to 1 by 2. Here B and B will get cancelled out and you will get 1 by 2 raised to the power y is equal to 1 by 2. Means the value of y will be equal to 1. So we just have calculated the value of y that is equal to 1. Let's consider the set 1 again. For set 1, this is the set 1. For set 1, rate is equal to K, A raised to the power x, B raised to the power y. Here I have placed the value of y that is equal to 1 is equal to R. For set 2, when we double the concentration of both the reactants, if we double the concentration of both the reactants, here concentration of A is equal to 2A and concentration of B is considered to 2B. On doubling the concentration of both the reactants, rate is increased by 8 times. That means rate 2 will be equal to A 2A raised to the power x multiplied by 2B raised to the power 1 is equal to 8R because it is increased by 8 times. So it is the equation 1 and it is the equation 2. Now divide both the equation. So you will get K multiplied by A raised to the power x multiplied by B divided by K multiplied by 2A whole raised to the power x multiplied by 2B is equal to R over 8R. So R and R will get cancelled out. B and B will get cancelled out. K and K also will get cancelled out. So you will get A over 2A whole raised to the power x multiplied by 1 by 2 is equal to 1 by 8. So here we can divide it. So you will get A over 2A whole raised to the power x is equal to 1 by 4. So A and A will get cancelled out and here you will get 1 by 2 raised to the power x is equal to 1 by 4. So the value of x will be 2 and value of y we have calculated as 1. So the rate law will be equal to rate is equal to K A raised to the power 2 multiplied by B raised to the power 1. So option C will be the right option for this question. Now come to the next question. What is the activation energy for a reaction if rate doubles when the temperature is raised from 20 degrees centigrade to 35 degrees centigrade. Value of R is given 8.314 joule per mole per Kelvin. And these are the options. This question can be solved by the using Arrhenius equation. According to Arrhenius equation, log K2 over K1 is equal to EA over 2.303 R multiplied by 1 by T1 minus 1 by T2. Here we have to calculate the activation energy. T1 is given 20 degrees centigrade, T2 is given 35 degrees centigrade, and rate will be doubled. That means K2 will be equal to 2K1. Before placing the values in the given equation, you have to convert temperature from degree centigrade to Kelvin. So you will get T1 will be equal to 20 plus 273. So you will get 293 Kelvin as T1. T2 will be equal to 308 Kelvin. Now place the values in the given equation. So you will get log 2K1 over K1 is equal to EA over 2.303 multiplied by 8.314 joule per mole per Kelvin multiplied by 1 over 293 minus 1 over 308 Kelvin. So here K1 will get cancelled out with K1. When you take out common Kelvin, so you will get Kelvin out of the bracket, and this Kelvin will get cancelled out with the Kelvin. The value of log 2 is equal to 0.301. So here you will get 0.3 is equal to EA over 2.303 multiplied by 8.314 joule per mole multiplied by 308 minus 293 over 293 multiplied by 308. So here this will equal to 15. Now rearrange this equation to get the value of EA. So you will get EA will be equal to 0.3 into 2.303 multiplied by 8.314 multiplied by 293 multiplied by 308 divided by 15 joule per mole. When you solve this equation, you will get EA will be equal to 34,500 joule per mole. But in the options, values are given in kilojoule. So you have to convert this value into kilojoule by multiply it by 10 raised to minus 3. You will get EA will be equal to 34.5 kilojoule per mole. And it is closer to the value of B. So the option B will be the right option for this question.